screen. Entire screen. I hope you can see the screen, right? Okay. Can someone confirm, please? Am I audible and you can able to see the screen?
Yes, sir.
Okay. Thank you so much for the confirmation. So let me put it in the presentation mode. I think in the last class, we were discussing about the information network and the technology related thing we were talking. So basically what we did is that we looked at various topologies. So what the network consists of and types of LANs, right? Like star topology, bus topology, ring topology, etc. Some hybrid models. Then we looked at the campus network, which consists of the FTDI ring, which is just nothing but a multiple LANs are going to be interconnected with the help of this FTDI ring. So then the wide area networks, what services, the medium or mode of transmission that we saw. Then WAN topologies. Then we started looking into the Ethernet in detail with the various standards and what is the distance that they can cover. Then we looked at the data format or frame format for the Ethernet. Then we also looked at bridge Ethernet and switched Ethernets, where multiple things can be connected through the switches and the bridges. Then we talked about the virtual LAN and then the fast Ethernet. So various data rates in the LAN, like gigabit Ethernets, etc., virtual LAN. Then we looked at various node elements in the computer, hub, bridges, switches, gateways, routers, etc. We looked at. Okay. Then the gateway. Then we looked at tunneling, which is one of the mechanism of which was used in the earlier X.25 networking model. Then we looked at the transmission model, various modes of transmission. Then we saw some problems, around 3 problems. That's what we did in the last class. Any questions, guys? Take 1 minute. If you have any questions from the previous class, you have to answer. All right, then we'll go for that today's session, which is session 3, which talks about the network management, standards, models, and the languages being used in the network management. Okay. What we are going to consist or today cover is that theory, techniques, and architecture for the network management. The whole network management consists of manager and the agent combination. So that architecture we'll see. Then service management, telecommunication management network. Then we look at the fault tolerant configurations or FCAPs, whatever we discussed in the last class. Then there is something called as the ETAM, which is called the Enhanced Telecommunication Operations Map, that we will go to talk about. The last class, I think I gave a little things. So again, the final version of the evaluation scheme has come out. So There is a lab sheet 1, lab sheet 2, lab sheet 3, which will carry. So 3 plus 3, 6 plus 2, 8 marks. Lab assignment will carry 7 marks. And Viva OSE will be around 5 marks. I repeat, 8 for the lab sheets 1, 2, 3, 8 marks. 7 marks for the lab assignment. 5 marks for the Viva. So 1, 2, 3 and lab assignment will be evaluated by TA, teaching assistants, which you will not interact with them. Okay. And even please raise the concerns only to those, not to us, because we will not be knowing what you have submitted, what you have marks you got, etc. But we will award that 5 marks based on the questions with respect to your lab sheet 1, 2, 3 and the lab assignment. Okay, that's the. Then every day in the class now onwards, I mean today this session onwards, session contact session 3 onwards, we'll conduct the end session quizzes. So all of you know that there will be a 15-minute thing. 5 questions are there. You are supposed to answer. So please, I'm telling you, this marks is carrying a 10 marks. So don't ignore, don't take it as a light. Try to attempt the quiz and try to answer the things. The average of all the quizzes that we conduct, maybe we conduct around 10 or 12, depends on the further availability. So that's where I'm telling you or suggesting you to participate and make sure that you get some score out of it, which will help you in the final grading. Okay. Then rest of the things is 30% for your mid-sem and 40% for your EC3 component. That's the. Okay. All right. So any further questions for you? Okay, we can start then. Okay. So standards, what we cover is various standard organizations are there like ISO, IEEE, IEEE, ITUT, like that. So many things are there and they have their own standard protocols and within the transport layer and other management layer or application layer, they might introduce a different protocols. Then management models and the language being used in the this management thing we'll see. First is OSI or CMIP. OSI stands for Open Standard International. OSI stands for Open Standard Interface, and it is an international standard. Then followed by the, it's a basically a management of data communication network using or for the LAN and WAN basically. This deals with all the layers, 7 layers that we discussed as a part of the OSI reference model that will be covered as a part of this. So this is the most complete networking model and it is based on the object oriented. Every layers are well structured here. And there is a clear-cut differentiation between the layers and the services or the protocols that they are carrying. And the only problem is that it consumes a large amount of resources while implementation. Whenever we want to implement, so it consumes a larger. SNMPR Internet is the industry standard based on the TCP/IP reference model. So originally intended for the management of various internet components, currently updated or adopted by the wide area network and telecom systems. This is also easy to implement and most widely being used. Next is a TMN, which is called as a telecommunication management network. It's a management of telecommunication network, basically. This is also based on the OSI reference model. Then this addresses both network and administrative aspects of the management. IEEE standards adopted the internationally recognized thing. Addresses both LAN and WAN management. Adopts OSI standards significantly. Deals with the first two layers of the OSI reference model. So then the web-based management is also there, called the web. So web-based enterprise management and also Java management application program interface called the JMAPI. So lastly, we touch upon this WebM and JMAPI. Otherwise, most of the things are good based on the TMN only. Any network management consists of the organization model, information model, communication model, and the functional model. So organization basically talk about the architecture, information which is going to be talk about the database kind of thing. Communication model talks about the how they communicate or data transfer takes place. Functional model describes the functionality of the things. The organization model, network management components, functions of the components, relationship that will be discussed in the organization model. Information models talks about the structure of the management information, which you call it as SMI. Then management information base, MIB we call it. That is mostly in object oriented in nature. Communication model talks about the transfer of syntax with the bidirectional messages. Then the data unit, the protocol data unit, which is being transferred in the communication model. Functional model talks about the application functions, configuration components, monitor components, then measure the performance, secure information, usage accounting, etc., which is basically covered with our FCAPs. FCAP stands for fault tolerant, then configuration management, performance management, security management, and account management are the things. That is where FCAP stands for. So TMN architecture consists of the any management related issues in the telecommunication networks are addressed by this TMN. This is based on the OSI model, then superstructure on the OSI network. So addresses network, service, and business management aspects. Anyway, this diagram you have seen already. There is a telephone exchange offices which we connected. So transmission system and exchange thing will be there in the telecom network. And data communication network will have the workstations and the operating systems for this entire thing. So this term telecom operations map will try to map the service management with the network management, and below that is the infrastructure, physical infra. Yeah. So there is a element management or technology related to the physical network and the information technology. Then the network system management process will be like, with respect to the planning, development, provisioning, then inventory of the stocks, maintenance and restoration fault. That's what I told you. So then the whole data management within the network is done by this network management layer. So then we have service development and operation process, which is planning and development again, service planning and development, service configurations, service problem resolutions, then service quality management, rating and discounting will be the service management. Then finally the customer care process, which will talk about the sales, order handling, problem handling, customer quality of service management, issues being dealt, invoicing or the collections. Then we have the customer interface management process, and finally on top customer will be there. This entire thing is supported by the information systems management processes. There are a lot of processes which are involved that will be provided. So ETOM is a comprehensive industry agreed multi-layered view of the key business processes which are required to run an efficient and agile digital enterprise. So there is a customer, there are complementary providers like free softwares, third-party service providers, function or process suppliers, and then there is also hardware, software, or many vendors will going to help you. So there is a provider and customers, CRM, customer relationship management. Yes, CRM is the supplier or partner relationship management. That's a very good. Otherwise, if no proper understanding, then this will lead to the flop show. So there is a implementation of decision support, awareness creations, billing, customer care, fault management, configuration management, performance management, traffic management. These are the So in case of billing, data collection, data discounting, and final invoice being generated. Similar to your mobile bill, maybe you can think of. So then there is a customer care centers. They will go to handle the orders if any customer queries are there. So customer information analysis will be done. If any problems, based on that, problem will be fixed. Or if it is a new request for the installation, so installation will be done and service activation is going to be. In case of fault management, so supervision, fault analysis, and then the maintenance across the things. There are a lot of workforce administrations are there. They will take care of the entire restoration. The configuration management is just nothing but the design planning and configure the entire thing, then followed by the software and the network provisioning, which will going to handle the configuration for the future. Performance management basically measures the results, analyze the performance, whether it is good, bad, etc. Then setting the measurement threshold, so that is important. You have been promised with some parameters, that parameters need to be fulfilled. So traffic management is traffic monitoring, traffic analysis, and rerouting of the entire thing. So this is what in the other view, fault management, inventory, quality of service, billing, service activations are the, which are the major processes. So as we told, there is a management entity. Then we call that as a network management station. There is a big network, which is called the network management protocol, which is used to exchange between the things. There is something called as the agent or managed devices and the managed databases. For example, say managed device is your mobile, then mobile related thing will be there. If it is going to be a network element, so that related to that PC or workstation will be there. So this is what we basically get to know the details. Agent, managed devices, management, database. So organization model describes the component of the network management and their relationship. Network management components are three things. One is manager, agent, managed objects. I repeat, this you have to be very, very careful, and this is the most fundamental thing. And our entire subject is based on this network management components. Manager, agent, managed objects. What is manager? Basically sends request to the agents and will keep on monitor the alarms. All the applications are inside this, provides user interface. This is the manager components. Agent basically sitting on top of the managed objects, try to gather the information from the objects, managed objects. Configures parameters of the projects, objects, sorry. Responds to the manager's request, whatever the manager is trying to looking for, so that it will provide. Then generates alarms and send them to the managers. Agent is built into the network element. For example, say there is a hub, there is a router, there is a switch. On top of this, agent will be set. An agent can manage the multiple elements such as switched hub, ATM switches, etc. What is managed object? Managed object is just nothing but the network element that is to be managed. It basically contains the management agent. All objects are not managed. They can be are manageable. Whichever the elements that we can manage, they are called the managed objects. They should be intelligent enough. They should house the what we call the agent, and they should be always available for communication purpose, etc. So that is called as a managed object. This is called as a two-tier network management organization model. Any manager means there should be managed database should be there, MDB, and manager will coordinate with the agent. The shaded process, shaded thing area is called the agent. Okay, this is the agent where it sits. So, as I told you, not all the objects can be managed. So some of them cannot be managed also. All the managed objects, we interface the agent, and for those unmanaged objects, we will not interface the. So agent will not be there for the unmanaged objects. Three-tier model, manager, either it could be a agent or manager, and below that managed objects are. Means three layers are, or three tiers are there. So MDB, see everywhere if you say manager, then it is a database should be there. Like that. So these are the agent processes. There is something called as a manager of managers. manager of managers. So this is one three-tier architecture. This is another three-tier architecture or two-tier architecture. These entire thing can be monitored with the manager of managers. So this will have its own database. This will have its own database. This will have its own database. So these are the agents NMS. This is the agent processor and different managers. This is one manager. This is manager 2. Both of them will be done. Any questions so far? So we call it as a peer network management system. So neighboring things will be interacting like this. Agent NMS might send something to the manager NMS. Agent NMS may request from the. So basically, dual role of management process is played here. Agent can be replaced or interchanged with the manager, and manager can be interchanged or replaced with the agent. So both are possible and it is adequate. So three trees in the network management. One is called the inheritance tree, containment tree, and registration tree. So basically, when we talk about network, most of the time it will be hierarchical in nature. Then hierarchical in nature. If that is the case, so there is a various components like network element, your node or a switcher or the Ethernet switcher. They are the components of the inheritance tree. How they are component. Then containment tree is going to have the network element or a module or an interface and the physical addresses corresponding to that. Then registration tree is the complete network thing, ISO, ARG, Department of DOD, Defense, Internet, then the management aspect. You will see the trees in the coming slides. Network management model, or it's an information model, which is just nothing but a manager of managers. Basically, there are two network domains. One is network domains which are managed locally and global view of the networks which is managed by the manager of managers. And second category is the agent NMS which manages the entire domain. Agent is also similar to manager only. It has a capability to domain may be a geographical, administrative, vendor specific, products specific, etc. So it is an area, or it could be an administrator, or it could be vendor specific products will be the domain. This network management systems runs a management processes. Both agent and manager devices are called the agent NMS and the manager NMS. Also important that the manager and the agent functions are processes and not the systems. Network management system acts as a peers and both the network management systems are having a dual role. The information model is going to have a dealing with the structure and the storage of the organization. How it is being stored or how the data is organized, that will be dealt by the information model. Yeah, you have a question? I think someone is speaking there. Someone spoke. Do you have any questions? Okay, no questions. Then I continue. So after the information model, and let us look at the what is the components which are there within the management information model. Basically, both object and informations are relevant for their management. One we have is SMI, which is defines the syntax and semantics of the management. Information stored in the management called the MIB. Then management information base, MIB we call it, which is used by both agent and the management processes to store and exchange the management related information. The MIB associated with an agent is called as an agent MIB, and the MIB associated with the manager is designated as the manager MIB. The manager MIB consists of information on all the network components that it manages, whereas an agent MIB needs to know only its local information, not the global information. Local information is good enough as an agent MIB. So as you can see that a lot of managed devices are there. There is something called the router. These are the network elements or the nodes. So there is an agent attached to these devices, and each agent will have something called as a MIB, that is management information base pertaining to that particular device. How do they communicate? We will see in the communication model. So it is only a storage of data related to the or information related to the devices. MIB contains data of the managed devices or managed objects. So one is the network elements like hub, bridges, routers, transmission facilities are called the network elements, including node also. Software processes basically programs or algorithms or the protocol functions and databases are called the software. Now to be managed, you need to have administration information, that is the contact person, account number is called the administrative information. Now, this entire information model can be structured and storage of the information in two parts. One is structure of the management information and the management information base, MIB we call it. SMI, structure of the management information, MIB is the management information base. SMI defines the syntax and semantics of the management information, and MIB it's a conceptual storage of management related information. Now this is how a SMI looks. So basically SMI defines for a managed object syntax, semantics, plus any additional information such as status. Example, sys description, system 1 is the system 1 we call it, the description is system 1. Syntax is acted string. So anything which is being stored is just nothing but an acted string only. So a textual description of the entity is the definition. Access could be read only, write only, read and write only, like kind of. Status is mandatory. So what you need to understand here is SMI is a basically syntax and semantics is what SMI talk about. How it should be, how the data should be organized in the MIB. That will be defined by the SM, structure of the management information. MIB is management information base, which contains the information about the objects, which are organized by the group of related objects and defines the relationship between them, between the objects that have been combined. But it is not a physical database, only a virtual, and that it compiled into the management model. Agent MIB versus manager MIB, or we can also call it as a manager MIB view, we can say MIB view. Managed objects can be network elements, hardware or the system, hubs, bridges, routers, transmission facilities, etc. could be the network elements. So then there is a software which is non-physical again, which consists of programs and algorithms. Administrative information like contact person, name of the group of the objects, or IP address of the entire thing, or IP address of this entire group, something like that. So then management information trees is based on the managed objects which are uniquely defined by a tree structure. Tree structure as per the OSI model, we call it as a MIT, management information tree. So as you know, when we say tree, it will have a multiple hierarchical in nature, first point. Then tree consists of in degree, out degree, levels are there. At any level, at most maximum 2 nodes can be, every node can branch into left and right, correct? So that is how it is going to be done. Again, this tree can be complete tree or non-complete tree. Complete tree means at every node should have exactly 2 outgoing nodes. Sometimes it may not be true. That's why it can be lesser also. For example, say if you look at the root is there at level 0, only 1 node. Level 1, 2 nodes are there. Again, these 2 will give 2 each in the next level, that is level 2. You can see that 4 nodes are there. Level 3, you can see only 1 node. That's why it is incomplete tree, not a complete tree. If suppose a level 3 also there are 2 plus 2 plus 2, 6 plus 2, 8 nodes are there, then we can say complete tree. Complete. So this is how the MIT. So designation ISO 1, organization 3, that is 1.3 it becomes a. Then DOD Defense, Department of Defense 1.3.6, Internet 1.3.6.1, like that. These are the standard numbers. So if it is ISO 1, no, ITU 0, then ISO ITU, then it is 2. Like that, it will be defined. Like that, it will be. Management information trees, which is just nothing but a what we call the complete thing which will be mapped into your local system. For example, say root, then ISO 1, identified organization 3, 6 is DOD, internet is 1, then management is 2, then system. So basically, when we identify the system, we go with respect to this MIT structure, which consists of root.iso dot identified organization dot DOD dot internet dot management dot system, or 1.3.6.1.2.1. That will give you the complete path. Okay, is that clear? So now if you look at for the other things, there are other numbers are there in the different hierarchy of the input tree. So management information example happen in the browser also, it looks like this. So MIP tree can be looked at like this. So you can also call it as a 1.3.6.1.2.1.2.1 basically of the. So each object type has a unique identifier, which we call it as a OID, object identifier, and the name, which is called as a descriptor given to the name description for that. So object type consists of name, syntax, definition, status, and access. So this syntax is what we defined in this particular thing called as a SM. Syntax descriptor, syntax, definition, access, status. Okay. So then object instance, each object type has a one or more instances. Any number, because object oriented itself is what we call it as this thing, right? So any number of objects can be created. System name, octet string, the name of the system, mandatory or read only like that. The object type, object ID and the descriptor, and then access privileges, syntax, the model of the object, then definition, semantical textual description, status is the implementation required. So this managed information communication architecture, which is going to be a basically so as I told you, managed object instances in the form of MIT. So what SMI or the definitions are looking for. Then there is an agent and followed by the some of the things like how to communicate with them, etc. This is the IEEE communication thing which was published in the 1993. So that period. So this is how it is. System managed object class derived from top, characterized by the system package, which is called a package. Attributes like system ID get, operational state get, etc. Notifications, object creation, object deletion, object name change, blah, blah, blah. Conditional packages include daily scheduling or external scheduler package, attributes like that. Then abstract syntax notation 1. ASN.1 is a more than the syntax, it's a language by itself. It addresses both the syntax as well as the semantics. There are two types. One is abstract syntax and the other one is transfer syntax. Set of rules that are specified by the data type and the structure of information storage is called the abstract syntax. Transfer syntax is set of rules for communicating information between the two systems. So makes application layer protocols independent of the lower layer protocols. Can generate machine readable code in the form of BER, we call it basic encoding rules, is used with the management model. That is the ASN.1 or abstract syntax notation 1. So user application component. So there are encoding rules are there. So local storage के लिए the data will be mapped. So for the syntax data transfer between the two users to happen, then the syntax transfer syntax will come, or between the application to application, then it will be an abstract syntax notation. See, abstract syntax notation, which will communicate between an application to application, and transfer thing comes into data transfer components. See, if you look at this, both the users, same setup will be there here. Application component, local storage, data transfer component. Now the protocol which is going to be exchanged between the application component is in the form of ASN, and transfer of data will be done by the transfer syntax. These are the standards and applications using the ASN.1, which is abstract syntax, and the transfer syntax. Both are part and parcel of this. Very, very simple types like basic types, character, distinct types, etc. being used here. Date and times are also there. Date and times, type definitions, subtype definitions, value assignments, OID, object identifier type, structured type sequence are set of things. Context specific tags, etc. will be described in the AS dot. PER is a basic encoding rules, type length value rule, type tags, encoding of identifier field, encoding of tag classes, or tag numbers, length field, integers, sequence of this thing. Then alternative encoding rules could be a PR, DR, or a CER. So what is being adopted in the network management system is a BER only, but alternate are also there called the packaged encoding rules, distinguished encoding rules, canonical encoding rules, etc. So the model is called as the internet perspective. Any managed object in the internet model is defined by the below 5 parameters: object identifier and descriptor, which will have a unique ID, name of the object. The syntax used for the model of the object. Access privileges to be managed like read or write. Status includes implementation requirements. Definition. The textual description of the semantics of the object. So the conceptual view of managed objects is a consider the object and it is a circular in nature. Syntax is circle. Semantics is the a plane figure bounded by a single curved line, each of that point of which is equal distant from the point of the center of the figure, or textual descriptions like a ring or dots. Access, an object can be viewed and its parameters changed by people who have access to it. Status, implementation requirements, that's the status of it. The conceptual view looks like this: object type packet counter, syntax counter, access read only, status mandatory, description counts the number of packets. This is called a packet counter object. So any OSI perspective, type means object class, attributes, operations, behavior, notifications, etc. will be informed in the form. So packet counter, single valued, then get set is the operation. So behavior is to retrieve or reset the values. Notification generates the notifications on new values. Correct? So this is packet counter, internet perspective. So this is OSI perspective. This is how it looks. This NM model, communication model, basically three aspects need to be addressed here. One is transport medium, the message exchange, that's called the transport protocol. Message format for the communication, that is application protocol. The actual message is just nothing but the commands and responses, or requests and responses, or notifications and traps. It could be anything. The language for describing this is your ASN. So this ASN.1 was formally defined by jointly ITUT and ISO. So both will going to use this. Both abstract syntax and transfer syntax are going to be defined as a set of rules in order to identify the types and structure of the information. And transfer syntax will represent the set of rules for the data communication. It happens between the two. So based on the Bacchus system, the formal syntax language and a grammar of Bacchus norm form BNF is being adopted. Name within the angle bracket, double colon equal to, that is the definition. So this is the BER is used in the management modules to convert an ASN dot filter of the machine. Sorry, I got a call. Okay, this basic BER will be used here. So for communication purpose, we have a formalized set of rules, which is as per that agreed only we have to send and receive. There's a language, syntax and semantics, which is ASN. So ASN is just nothing but defined as a set of rules which are used to specify the data types and the structure for the storage of information. For transfer, syntax represents the set of rules for communicating between the two systems. So based on this Backus norm, I think we covered this, right? Okay. This is how it looks basically. ASN.1 makes it independent of the lower protocols. Name, high definition, entity denotes an entity. Symbol represents the defined as double colon. So then the digits can be represented as a 0, 1, 2, 3 up to 9. The symbols can be something. Operators could be plus, minus, star, slash. Number could be a digit or digit followed by a number. Multiple sequence might repeat. Then the number 9 is the digit 9. Number 19 is the concatenation of the digit 1 and 3. And similarly, 219 is the concatenation of the digit 2 and the number 90. Like that, it goes the syntax. See, mostly we may not ask you to read the things, but you should have a basic knowledge how it is represented, what is this digit, etc. Because these are all based on the language. So ASN has multiple types of Boolean, which is just nothing but a true or false. Door open Boolean equal to true. So integer, it is a varies from 0 to 60. So bit string, it is just nothing but an array. Every character is represented by 8 bits. Sensors is equal to bit string, door open is 0, window open is 1, engine open of 2, like that it will be closed, sensors. My status sensors is equal to window open, engine on. So that's how the types. Then acted string is just nothing but a hexa representation of the things followed by H. Date will have the format called as a 4 Ys MMDD. Time of the day, hour, minutes, second. That's the format. Date and time put together, it's a string of this thing. Date and the time. Enumerated data. So sometimes you can use the enumeration data like black, red, white colors. So that for colors. Object identifier used globally unique identifier. So that's why we may use identifier numbers. Like for example, say ITUT 2, country 16, US 840, organization 1. These are all the object identifiers. So sequence is just nothing but when you have a collection of items to group together. So it's a sequence. Name, visible string, phone number string. The driver contact name is Jan Smith, phone number is this much. So sequence of used when you have a list of array of repeated items. So that's why it is called a sequence of. So for example, say break time sequence of times of the day, which is 10 o'clock, 12 o'clock, and 245. Choice could be used when you have a collection of items for which only one of the items can be represented at a visible string. So whatever that used in your things, which is a subset of ASCII that does not include the control characters. Null is used when you need a placeholder, empty, nothing is to be mentioned, then null can be used as a. Any questions so far? All right. So these are the types of specify, translate, build, run. Write your protocol data specify in the ASN.1. So compile with the help of this, then build with the OS, run for your plot. So we have a compiler, we have a IDE, we have a decoder, etc. So this is how the communication takes place. Current status on, next state action is the turn on. So based on this, we can have a different communication which takes place. Weather report sequencer, station number, then time of report, pressure, temperature, humidity, wind velocity, wind direction. So basis this, now you can see station number is 73290. So this is the syntax. This is an example. So 73290 and this is the time of report is 9001 02 12 5703Z. Pressure is 1056. Temperature is -3. Humidity is 26%. Like that. And wind velocity is going to be 15. Wind direction is 0. Again, for a personal record, it's a set name, graphic string, division choice, marketing 0 sequence, sector or country. This is an enumerated data like that. So Smith manager designation. So circle north, country Chile. Okay, so that's how it will be placed. Module name starts with the capital letters like null, graphic strings, etc. Constructs could be alternate choice, list maker, set or sequence. Repetitions is a set of or sequence of. The difference between set and sequence is that a sequence is a model, an ordered collection of variables of different type. Sequence of is models and ordered collection of variables of the same type. Set of models and understood unordered collection of variables in different types. Set of models and unordered collection of the variables of the same type. Choice specifies the collection of distinct types from which to choose one type of the data. Okay, so sequencer where multiple sequences are keep on coming at that time we can use that. So different modules and the symbols. So module name, then definition begin, name of definition, that is the module. If any symbols you wanted to use, you can use this double colon equal to, then alternative or R mention, sign number, following the symbol or components. In order to start and end the list, you can use this. In order to use the tag, use the square brackets. So start and end at the type, subtypes, you can use small brackets and dot for the range. Network management, secure email, cellular telephony, air traffic control, voice and video over the internet. More information on the tools integrated seamlessly with various platforms. The newly defined syntax, XML encoding rules, etc. Now, lastly, we have this function models, the network management function model. As I told you, fault management, configuration management, accounting management, performance management, security management. That is, we call it as easily to remember FCAPS. So this can be broadly divided into monitoring and control. So fault management is just nothing but the detection and isolation, response for the correction if possible, logging, immediate handling of the transient network failures, link, host, router, hardware, or the software outages, detection, location or service restoration, and networks can be a self-healing. So this is very important. Fault tolerant machines, we call it. That means if something goes wrong, that will automatically rectify, just like our human body. Trouble tracking systems with the help of tickets. Each ticket records the data about the problem and the action taken. Configuration management determines the setting of configuration of the devices normally used in the discovering of the topology, mapping, etc. So thus use a broadcast ping or an examination of the ARP caches and the local router is what an example we can give. So configuration management also covers the network provisioning as well as the network planning and design. Account management, which specifying the logging. So how many users logged, at what time they used, how much they consumed, what is the device that they have accessed. So gathering all these statistics is what we call it as account management. Example, querying activity logs on a individual host or a traffic counters from network devices such as bridges, routers, and switches is an example of an access. So performance management is just nothing but a quantify, measure, report, analyze and control the performance of the different network components. Data traffic management, which involves the data management also. And also it helps in data monitoring, problem isolations, performance tuning, statistical trend analysis, and other resource planning. Performance also gives parameters, or performance is measured on throughput, response time, or network availability, and the network reliability is going to be what we call as a performance. So security management is just nothing but controlling the access to the network resources, including information stored and being transferred. According to a well-defined security policy, and identify that which is to be protected. A security database is established and maintained by the network operating centers, Unauthorized access to the database or a network will generate the NMS at alarms are going to be generated so that you can come to know there is some unauthorized access is there that should not be allowed. Okay. So that's the thing for to be covered. Now a small quiz is there for about 15 minutes. I hope all of you have received it, right? Let me first stop recording.